Hello and welcome to the Sci1 YouTube channel. My name is Ray, and in this video the Microsmt OpenPNP setup part 3, we're going to continue with setting up this machine. Now, where we left off last week was with we'd got most of the mechanical configuration done, and we'd done a little bit of optical configuration, that is setting up the top camera. So now we're going to move on to the bottom camera. So after hitting find issues and solutions, we've got two fundamentals that we need to deal with and a heap of suggestions before getting onto the milestone. So let's start with our first one. We need to determine the up camera or the up looking camera bottom position and initial calibration. So the easiest way to do that is to move the nozzle N1 over the up looking camera. So at the moment the system has turned on the top light, and that turns on the bottom light. We're looking through the bottom camera. So what we're going to do is set this to 10mm increments. And I'm just going to make sure there is a nozzle in there. There is. And I've actually got nozzle 2 close to it, so and that's nozzle 1, dropping down to 1mm increments. Wrong way. Point 1. I'm going to zoom in a little bit. That looks pretty close. Use autofocus recommended. Don't know that this camera supports autofocus, but we will give it a try. We're going to use auto detect feature diameter. It's saying 32, so let's accept that. It's now going to run through the calibration process. What it's doing is actually moving the head around a little bit and moving the nozzles up and down and taking various photos just to make sure it can see it and detect. By moving the camera around and taking photos at different positions, it can calculate out the resolution of the camera, and using the nozzle at different heights at the same time, it can actually estimate the spread of the camera, the focal angle, and therefore get a reasonable idea of the position of the camera. So it's happy with that. Okay, so our next fundamental is use an adaptive camera settling method. For precision in computer vision, it's very important that the camera images settle down after the machine has moved. So let's give it a try. So we'll hit accept. And it seems happy with that. Okay. So let's just make sure that that's all good. It's still open. Let's try this again. And that one's solved. Okay. A high preview frame FPS or frames per second value might create undue CPU load. Set to 5 frames per second. So we'll do that. It's recommended to suspend the camera preview during machine tasks. So we'll do that as well. In single camera preview, OpenPNP can automatically switch the camera for you. Enable auto camera view, yes. Preview render quality can be improved. Set to render quality to high, right click the camera view to see other options. I think we'll just go with that. Okay, so now we've got more to go. Contrast of the top camera should be at 38. Gamma of the top camera should be at 400. Saturation of the camera should be set to 64. And white balance of the top camera should be set to 4600. Calibrate the static white balance for the top camera. So we'll accept that. Okay, so I haven't got a grayscale. And I don't have a white balance calibration object. So this is what I'm going to have to come back to. So I'm going to dismiss this one for now. We will suspend camera preview during machine tasks. Camera in single camera preview, OpenPNP can automatically switch the camera. We will do that. And preview rendering quality can be improved. Set rendering quality to high. So this is for the bottom camera. The contrast of the bottom camera should be set to 38, which we'll do. Gamma of the bottom camera should be set to 400. Saturation of the bottom camera should be set to 64. And white balance of the bottom camera at 4600. And calibrate static white balance for the camera. Again, I haven't got the target for it to do that with, so I'm going to dismiss. Now, I thought I'd done all of these. I'm sure I did all of these, you know. No, it's not going to do it. It hasn't accepted them, but it did go through. All right. Calibrating of the backlash for the x-axis with a tolerance of 0.025. So let's give this a try. Now it's running through. I'm just going to bring the camera up so you can see this moving as it goes through the calibration process. The backlash calibration can take some time, and depending on the settings you have, may yet fail. So what it's attempting to do here is work out at different speeds, different distances travelled, when it has to start slowing the head down in order to hit exactly the mark that it wants. Once it's established a range of slowdown, it'll adjust the backlash compensation settings in order to hit a very precise position. So with our homing, we can get to within 0.1 of a millimetre using the limit switches. Using fiducial homing, we can get to 0.025 of a millimetre. sometimes even smaller resolution, which is pretty impressive for something running on a set of stepper motors. This thing has a total of 5 stepper motors in it, one for the x-axis, which you can see in the right hand side of the image there. Up towards the back there is a second stepper motor which runs the y-axis. Then under the white cover towards the back there is a third stepper motor which moves the nozzles up and down. As one goes up, the other one goes down. Then each nozzle has a very small stepper motor on it to rotate it. So there's one for each nozzle. We'll only be doing backlash compensation on the X and the Y axis. And it looks like it's completed that. So if we go to machine setup, x-axis and backlash compensation, you can actually see the graphs here. So came up with a tolerance of 0.03 millimeters, which is not too bad. Sneak up distance 0.113. Now one of the things I have got that I can use to try and improve that is a new set of tensioning brackets to go on this machine. They actually arrived today for both the X and the Y axis. But let's give the Y axis a go using the issues and solutions section, and we'll start that. Okay, so let's have a look and see how that came out. And yeah, we got 0.03 tolerance, a sneak up distance of 0.453. So this one is got a little bit more slack in it than the x-axis, and that's one of the things I want to change with or improve on with the tensioning system that's come out. Alright, so let's go back to our issues and solutions and have a look at our next fundamentals. Calibrate precise camera nozzle N1 offset. Okay, to calibrate precise camera nozzle offset, we let the nozzle pick, rotate and place some small objects and then measure the resulting offset using the camera. Place the calibration test object onto the calibration primary fiducial. Jog the camera over the top of the test object to target it with the crosshairs. Adjust the feature diameter up and down to see if it's detected right in the camera. A green circle and crosshair should appear and hug the test object contour. Zoom the camera using the scroll wheel. Okay, now to do this next step, calibrating precise camera nozzle N1 offsets, we need to use a target. Now the target, turns out, is basically just a round paper dot, and you can obtain one of those by using a hole punch. So what I'm going to do is put that here, over the top of our fiducial, and we'll use that for that process. But before we do that, under machine setup, if we go to nozzle tips, reference nozzle NT1, it's got a default configuration, which is fine. Under tool changer, we're not going to use that. Actually, I'm in the wrong section. I want to go to heads, reference nozzles, reference nozzle N1. You can see we've got the NT1 tool changer. It's compatible and currently loaded. We have our offset for that nozzle, and under tool changer, what I've done is I've gone to our fiducial location and I've saved that. So just clicking on here and then apply that value. That gives us somewhere that we can manually load a tool at the moment, something that we didn't do or didn't have before. And I've done the same with N2. So I've just gone to my fiducial location and saved that position and applied it. Now that we've done that, let's go back to here. I've put my little white dot from my hole punch onto here. We need to do an auto detect at this point. So what it's doing is it's looking for that round dot. It's found it, which is cool. It's going to keep looking for a little bit more, see if there's something better. When it's finished, it comes back with a feature diameter of 162. I think that's in pixels. And we'll click on accept, and this will launch it into doing our calibration. So while this is doing that, you can see on the video view what it's actually doing. So it's looking at it, picking up the bit of paper. It's actually turning the pump on to do this, and the vacuum lifts paper up, rotates the nozzle, puts it back down, and takes another photo. Now, in hindsight, I probably should have used a slightly larger nozzle, and I might just rerun this with a larger nozzle. The nozzle I've got in is actually the smallest one I have, a CN040. And it has actually finished it. So I'm just going to swap out this nozzle. The nozzle I'm using is a CN110. Now, for those of you who are familiar with the pick and place machine, micro SMT pick and place machine, will know that this nozzle doesn't actually come with the machine. Alright, so if I go to the machine setup, reference head, and just go to our nozzle point, go back to our issues and solutions. I'm just going to reopen this and tell it to do that process again. I think it's doing a better job picking up that with the larger nozzle. Incidentally, a CN110 nozzle is more ideal for a 0805 sized part, which is the majority of what I'm planning on using it for. You'll see all those 8mm feeders in the front there, and they've got all 0805 parts in them. And that's now finished. So let's do the same thing for our N2. I'll move that bit of paper back first. I go to machine setup, center it, auto detect, looks like it found it. It came up with the same number as last time. Slight technical problem. So what we'll do, we're going to tell it to unload. It's better. Go to nozzle 2 and we will load. Alright, we'll make it compatible and then load. Try again. It's moving to the wrong spot. And I can see why looking at these settings. So one of them, the x-axis, we know that it's minus 22.388. The second one is, or the y-axis is minus 60.091. But when we look at nozzle 2, it's got the wrong value in it. So what I think I'll do is get this, copy that, apply that, I'll reopen this because it didn't work. It didn't move it at all, so as far as it's concerned there was no run out. So we'll see if that works. No, it's still going to the wrong location. It does definitely say primary fiducial location. It's still got the wrong setting in here. The reopen is what adjusted this. That's better. Now you may not be able to hear this through my microphone, but the pump is activating and opening the valve so I can actually pick up that bit of paper. So each time it picks up the bit of paper, it rotates the nozzle and then puts it back down. And this allows it to detect the run out on the nozzle. And that seems to be happy. So here's our results for our run out. So with this one, take the nozzle tip out of nozzle 2, put it into nozzle 1, and OK. Center the nozzle. Auto detect. And accept. And that's done. Right, I'm just going to move my little dot off the fiducial. Accept. So now it's doing an advanced top camera calibration using the fiducials. Now it should be able to get a more accurate calibration of the lens because now we have backlash compensation also in the mix, which gives us a much more accurate positioning of the head. Okay, so that looks like that's done now. So let's move on to our next one, which is the advanced camera bottom calibration. Now this uses the N1 tip, so let's do that. Well, this isn't making a lot of sense to me. It's saying it's doing advanced camera calibration for the bottom camera, but it looks like it's actually doing the top camera on the secondary fiducial. Unless it hadn't actually finished the top one. Okay, so for some reason it did list it as clear or solved, even though it hadn't actually gone through the process. So I dismissed it and then reopened it. and now I've got it going through the process of advanced camera bottom calibration. And this looks more like what I was expecting to see. So you can see here that the bottom camera has its light on and it's looking up and it's moving the nozzle around just to make sure everything is calibrated the way we're expecting it to be calibrated. So what it's looking for is if the nozzle is on an angle or if there's some run out on it, it's just making sure everything is right. It is rotating that nozzle around. Okay, this is interesting. Looks like it's still running, but it's having trouble estimating units per pixel. So I'm not sure what it's complaining about at this stage while it's still going through the process. The head's still moving. Okay, that seems to have completed. It's stopped moving. So I'm going to work on the assumption that that's correct. It is saying it's solved. This next one, I've actually tried setting this a couple of times unsuccessfully. So I'm going to dismiss this one. Same with this one. I've actually gone through and set all of these already, accepted them, and it just doesn't take it. So it's complaining about my NT1 tip diameter having a part diameter of 0. So let's change that. 1.000. I'm not sure what my tip diameter should be. I probably should have set it at 2 millimeters. Try 2.5. Apply that. It's happy with that one now. I think I might just rehome this. Don't know that I like the way it's calibrated that bottom camera. Yeah, I don't like the results of that one, so I'm going to disable this. And that looks better already. I think I might just dismiss that one for now. and that means we can do the milestone. This one I'm going to have to do a little bit of research on before I continue, and this video has been going for quite some time now, so I will call it quits for this week and come back continuing on from this point. So it's wanting to set up feeders and tables between tabs. So to see when I set those up, don't forget to click on like, subscribe, ring that notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to support the channel further, I do have both Patron and YouTube membership, and you can join my VIP patrons GoLucky, Jerde, and Keres Contorni, my Builder patrons Morales45, Andrew Cardone, and Airgar69, and my YouTube member Joel Hauxwell in helping to support the channel. All my YouTube members and my patrons get these videos at least a week early. If you have any questions, feel free to leave a comment below or drop into the Discord. There is a link in the description, and ask your question in there. If I can't answer the question directly, I might know someone who can. And we'll see you in the next video.